Hi, and welcome to the next chapter of my Hopper load cell project. We're going to talk about hardware abstraction in this one. And what do I mean by that? Well, in the first episode, I mentioned in the introduction that we're going to want to make this work on different hardware, like on this Challenger RP2040 with its own Wi-Fi, or on like this is an Adafruit board, but this one has a LiPo socket. So you can have battery power on it, and we're going to want to make it work with more than one display. Some of them have built-in buttons, some of them don't. So how do we do hardware abstraction? Well, we'll go back to our project, and we're going to make a new file. So file new, and we're going to put it in the same folder, and we're going to call it let's start with the Pico W hardware and .hs for hopper source, like that. And then we're going to make ourselves a unit in that new file. So we're in the new file, and we're going to make a unit called hardware. So that if we have something like, let's say we have something called initialize, and that's going to say success is returned true. That means that, and we can now move the board user statement into our hardware one, and we don't need to put a path for the hardware one because it's in the same folder as scale. So Pico hardware, like that, and we can put our users Pico W hardware. If I right click on it, nothing happens. It means I probably made a typo. There we go. And we include the board, and we have an initialize for now. So now we can have down here, before we call reset, let's just say if not hardware initialize. Now we can just put a, something like this. Failed to initialize hardware. Like that. Yeah. Okay. In fact, we don't even need that. I'll show you in a second why we don't need that. We'll just return on that. Now, some of this is hardware specific and some of it's not. And we want to move the hardware specific stuff into our initialize. The stuff that's specific is, the overclock is specific to the Pico W, but anything else that includes a pin number, because the pin number is not going to be the same on different hardware. So we can move things that are not specific to happen after the hardware initialize, like put that off to there. And this stuff here is going to be the stuff that's hardware specific. So this is going to be different depending on which board we're on. So let's take that away. And let's go to our initialize. We haven't built it yet, so it doesn't know where it is. If you haven't compiled it, it can't find the symbols yet, but it will soon. So there we go. Clock speed is set. Our button delegate, we're going to need to pass that in as an argument. And actually, that's not hardware specific. So let's take that back. Control tab is what switches between them. So the actual button delegate is not hardware specific, but initializing it is. So we'll pass it in here. And the other thing that's hardware specific is the pins that the cell is going to be configured to. Now, initially, cell is initialized to a empty cell, and so when we create a new cell with pins using create, it replaces the content of the cell variable with a different one. So we use a reference argument to pass it back through from the function. So that's what the reference argument's about. So we're going to need a reference here, and this thing here is a load cell. So what gets passed into the function is an empty load cell, and then we assign a new value to it, which is why it needs to go back as a reference, so that the new value gets passed back. Right. Now, another thing that we might want to do so that it's easier to understand what these pins are is give them names. So like const byte, and we know we've got, so what are these? Let's go look at create. There's a data and a clock pin, right? So let's call the one cell data, and that's GP15, and const byte cell clock, and that one's on GP14. And I'm just going to verify I got them the right way around. Data clock. Data is 15 and clock is 16. And then const by, and this is our tar button. So our tar button is GP13. There we go. Let's try building all that. And this, I just like building between making changes so that if I made a mistake somewhere and the thing stops working, I know at what point it stopped working. So now if we run it, we expect it to still do what it was doing in the previous chapter because we haven't really made any changes. And there we go. It's still doing what we expected, right? It's still working. Let's see the tar button still works. Yep. Okay. So now when we add new hardware, like when we add a screen, or we use a different board, we just do it. So when we add a new hardware, we add new hardware like the Challenger board, we'll add a new hardware file. But when we add new hardware like a new screen to this configuration, we're just going to add it in this file now. So that the main program can be the same across different hardware configurations, easier to maintain, one program for multiple hardware configurations. And the hardware specific stuff is going to be in this hardware unit. And even though the file name is Pico W hardware, the unit name is hardware. So when we change this to a different one, it'll be Challenger hardware, and it'll still be hardware here. And we'll just include the Challenger hardware one here. Actually, I'll just do it now quickly. So suppose we end up with the Challenger board here, like that. That'll be Challenger hardware. We comment out that one. We say file new. Oops. Challenger hardware.hs like that. And we make a new. Oops, didn't like that. Obviously messed something up. There we go. Hardware. Make a new hardware unit like that. And we make a new initialize. And it was a ref to a load cell called cell. And it was a pin ISR delegate. And I forget what we called it. I think we just called it pin button delegate here. Let's keep it the same just to make it easier to remember. And we're just going to pretend it was always a success. And then for this one, we're going to go users and another source, library, board. And what board's that going to be? I think it's the Challenger Wi-Fi, but I can't remember what it's called. That one, there we go. So it's this board. So Challenger, no battery, 2040 with Wi-Fi. So now we've got a second hardware configuration. There we go. And I'll build it. Error at build, didn't like it. Oh, no. What's wrong with that? Boards. It's an error before board, so it didn't find this file. It was because I put a typo in there. And that's why we compile things. There we go. Building, pre-processing, compiling. So our second hardware configuration, except for the fact that GP13 is not defined. So this attached to pin, that was a good find. That should be in the hardware initialize because it's specific to the pin number. So let's go and change that in our current hardware configuration. See, good to test things. go back to our Pico one, and we need to attach the pin. After we set the pin mode of the tar button, we need to attach it like that. And then if it fails, it's going to say fail to attach tar button, and return false as a failure. There we go. Let's build that, and then make sure it still runs on our existing hardware. Because I'd rather test than find out later that it doesn't run and not know where I made a mistake. Let's go Control F5, and there's our timer set, and there we go. And if we press the reset button, it still works. Very good. So there we go, hardware abstraction. And then in the next chapter, we'll add a display. Great. Thank you for watching.